I'm going to do a STATA tutorial to show how to summarize data, clean data, and do the bivariate and the multivariate regression, and also how to deal with the bias in our omitted variable situations, like in this case, how to decide the sign of this two terms multiplication. So here we will use the NELS 88 dataset, and by describe, we will show the dataset. And this is a list of variables that exist in dataset, and this could be used if you want to find any variable. Another method is to tap this little icon here, Variables Manager. And if we want to look for some variable, for example, if we want to look for some variable includes income, then we can tap in income, and all the variables that contains the word income will come up. We'll see that yearly family income is this variable, which we'll use later. And in this data tutorial, an example is to show how students' math score in 1988 will affect his income in the future. So we will look for the variable with math and income. The income in the second wave is and if we want to know some more detail about it, we see that there are negative values inside, indicating that there are not applicable data in the dataset. So we want to tab this variable to clean the data. And we see that there are negative values. And if we scroll down, so in this case, we'll recode this variable with negative values. And then we'll generate income of this student. We see that there are almost 1,000 data changes difference between the income and the original income variable. And now we'll clean the data for the math. As I have said, we can look for this student's math score. And this is what we want. So summarize. We can see that there are also negative values here, indicating that we have to clean this data. So look for some details about this data. Then we will have to clean these negative values. And furthermore, in this case, we have to clean these very big numbers, because they are kind of outliers in this variable. So we recode negative values and the huge big values, and we generate math. So we see that there are almost 1,200 difference between the original data and our generated data. So far I have shown how to summarize data, and how to summarize in detail, and how to tabulate data, and how to recode data. Then we'll do a simple regression of bivariate of income, the student math score in 1988. We'll see that the effect is significant with the t-score of 13.8 and the p-value close to 0, and the coefficient is 230. And we summarize these two variables to see whether this effect is large. We see that the mean of income is almost 25,000, and the standard deviation is 20,000. So 230 compared to the mean and the standard deviation of income is trivial, so we can speculate that math, in fact, income is very little. And this can be demonstrated by if we have a beta coefficient here, and we see that math beta coefficient is 0.136, which is very small. Then after doing the bivariate regression, we want to do a multivariate regression because a bivariate regression will not have the control variables, so the estimates will usually be biased. By controlling more control variables, we'll have more accurate and unbiased, efficient estimates. So what are some of the control variables that we want to include in our regression? We can guess that race is a common controlling variable, so we will look for this variable race and tab race. So we see that the last two categories are missing data, so we definitely want to recode that. And in terms of categorical variable, we want this no label to show the value of it so that we can recode it. And in this case, we want to know being white or not, the effect of being white on a student's income. So we will recode 1 to 3 as 0, 4 equals 1, and 5 equals 0, and generate white. And we'll double check a little bit. Yeah. So what are some of the other variables that will have influence on the student's future income? We may think that the student's family income in 1988 will have a positive relationship with the student's future income. So we want to, and this time we will try to look for variables in the variable manager. Total family income, we'll use this variable, bifamic. So sum bifamic and sum detail. And we want to tab it in order to see whether there are some outliers in the variable. Oh yeah, we see that the last two categories, it is an ordinal variable, and the last two categories are missing data, so we definitely want to recode that. And we'll press more to finish it. So we want the label, we want the value of it, so no label. So we'll recode the label value of 98 and 99 into point bifamic. So this is the family income. Alright, now so far we have 3 independent variables, and we want to test the effect of math score on students' future income given the other 2 control variables of race and students' family income. And we do this simply by regress, income, math, fam income, white. These are all the data that we have already cleaned. And with the beta here to compare the effect size of each variables. So now we can see that math has compared to the, we want to do it again. Compared to the first regression, the math effect has somewhat been mediated partially by the other 2 controlling variables with the t-score of 7.54, and family income has a strong positive relationship with the student's future income. It has a t-score of close to 10, and the effect coefficient is also larger than math. It is close to 1,000. And of these 3 variables, family income has the largest effect on future income in standardized units. We can see that whites variable has the smallest effect, and in fact is also insignificant as well. So now come to the last part. We want to know how to predict the effects of omitted variables in this case. So what are some of the omitted variables in our regression? One speculation might be the parent's education here. So we want to look at father's education in this case.